Okay, so before we begin the material for today, I just wanted to say something regarding the SCI410 students. So, for the SCI410 students, you should be aware that you have an extra assessment, the final project. It's due later on in the trimester, but now might be a good time to start. So it's worth 30% of your mark grade, and now might be a good time to start thinking about it. So the idea is that you find a topic of study that interests you, you find a paper related to that, you plan some analysis around that, then you do your analysis and you write a little report. Okay, so it's probably a good idea to start thinking about that now. So in the first week back from after the mid-trimester break, the lecture will be sort of a little bit of an introduction to some data analysis techniques in MATLAB. So the actual slides for that will be up early next week. So even before we actually do the lecture, you can have a look at the slides early next week to sort of give you more of an idea of what you want to be doing. Now the idea is not to replicate the analysis in the paper that you choose. I mean, they're more experienced than you, they have a lot more time to do it than you do. So the idea is not to do a complicated analysis like they do in the paper, but is to look at the paper, look at what questions they consider, and try to think of another question that perhaps they don't consider that might be interesting and might be sort of relatively easy for you to analyze. So the analysis isn't supposed to be complicated or deep, but identify a question which you can study using the tools that we've learned so far, and sort of the tools that will be presented in the next lecture after the break, whose slides will be available early next week on data analysis. Okay, so I just wanted to say that. So now is probably a good time to get started on that, at least in terms of identifying a topic of interest and finding a paper that has some data associated to it, right? You want to have some data associated to it. The journal PLOS ONE is generally a good journal for this. Most of the things we've taken have been from that journal. The reason why this is probably the first journal to go to is because they have an open access policy. So if they do analysis on data, the data will be publicly available most likely. So it's a good way to get publicly available data. But of course, you don't have to use articles from that. If you find an article in another journal that's got, you can access the data, then you're free to use that as well. Okay. If you're having real difficulty in finding a topic of interest or finding an article, then send me an email. I can help you out. Okay. So let's begin. So I just wanted to finish off these last few slides from last week talking about debugging. Okay, so bugs are what we call errors in programs, and there's different types of errors. So one type of error is a syntax error. This is where I guess you haven't followed the grammar of the language, so to speak. So if you're doing a string, you might have a single quote beginning it, but no single quote ending it, and MATLAB's going to complain to you saying, there's an error, I don't understand what you're doing, fix it up. Okay? By far, these are the most common errors, and MATLAB's going to tell you about them, okay? Before your program even runs. Then we have runtime errors or execution errors. These are errors that are found during the execution of your script. Okay, so for example, one thing could be, so you have a vector of length 10 in your script somewhere, and you're trying to access the 12th element, and that's MATLAB's going to complain. It won't complain before you run the script, but it will complain while you're running the script during the runtime. And these are a little bit tougher to locate and identify because the runtime error may not happen every time you run the script. So it may only happen for very certain input values from the user, and the user may not often enter those input values. So they can sort of just lurk in your code, waiting to blow up, and you sort of don't become aware of them until something bad happens. Okay, then you have logical errors, and this is sort of like MATLAB doesn't tell you anything wrong about your program, but you've made some error in your reasoning. So for example, let's say we're converting between centimeters, inches. Say you use this formula instead of this formula, so you essentially just got the unit conversion the wrong way around. MATLAB's going to do that perfectly okay, right? It's not going to complain to you at all. But your result's not going to make sense, okay? Logical errors are by far the hardest errors to catch because MATLAB won't help you, okay? So one way to get around logical errors is to test your program on input whose output you can work out without the help of the program by hand, and check that the program gives you the correct output, okay? Okay, so there are various methods available for debugging. So you can use the echo statement, which will show all statements as executed. MATLAB's got an inbuilt debugger. You can set breakpoints, so values of variables, expressions can be examined at various points. Okay, so let's just go back to some code from last week. So let's go doc echo to find out more about this echo function. Okay, so you can go echo on. So let's have a look at a fairly simple. So we have this Roman Graves analysis from last time, remember? Okay. So I could go echo on, then just run Roman Graves analysis. Okay, so it does the plot. Then it's going to ask me how many bins I like for my histogram. Okay, so here you see that it's actually telling me, printing the code as it's running, right? So I can see, so if some error happens somewhere, I can see exactly where it's going to happen. Okay, if I've sort of located, maybe let's go back to another week to demonstrate that. Week 5 might be better. Okay, so remember we had this script back a couple of weeks ago that printed a rectangle of asterisks, and let's say I have a problem happening somewhere in here, and I have a problem happening somewhere in this loop. Okay, so what I can do is I can come across here and click on here. That little red dot means there's a breakpoint here. So when I run it now, it's not going to run all the way through, but when it hits this breakpoint, it will pause for me, right? And I can examine the program at this point, right? I can examine what value, I hover over rows, it'll tell me what's in rows. I can hover over columns. I can hover over R, it'll tell me what value's in there. I can hover over C, it'll tell me what's in there. So I can inspect the values in my program to see if everything looks all right. And then after I've done that, I can continue. Okay, and it will pause again once it goes back to that. I can examine what's happening inside my program during its execution. Okay? I can quit the debugging, or I can just click on this breakpoint again to get rid of it, and then when I continue, it's got no breakpoint, so it's going to run until the end of the program. Okay? So breakpoints are a good way if you want to sort of pause at some point in your program and examine what's happening. Throw a breakpoint in there, run your program, you can just examine what's in variables. Okay, so it's a very handy thing to try out. So function stubs can be used to prevent bugs, and sort of, I guess it's an analogous way to sketching, right? So if you're a painter, right, usually you don't start painting what you want to paint straight away. You might sketch the outline of the objects in pencil before you start painting. So function stubs are sort of analogous to this sketching process. You sketch out the general idea of your program without starting to paint or starting to program all the logic in it, but you just sketch it out, and then after you do that, you sort of have an idea of the general structure of your program, how it all fits together, and then you can start painting or start filling in the gaps. Okay, so the general approach is, so you just create your main program, right? Your main program script. And generally what you're going to be doing is you're going to be calling functions that do certain things. Okay? And then for all those functions, you create your functions, but you don't fill out all the details of the functions. You just do simple things like you might print saying, now I'm calling function such and such, and you return dummy variables just to see the general idea of your program. Then after you do all this and you see everything sort of going all right, you then go back into those functions and fill it in how you'd like. Okay, so for example, let's say, so the actual stubs you write are sort of nonsensical, but they sort of mimic what the functions will eventually do, right? So let's have a look at this. We want to write a program that plots the amount of money in an account after n years at an interest rate I with a principal of P invested, right? So you invest P in some bank account. The bank account the principal earns an interest rate of I, and you're interested in the amount of money in that account after a certain number of years. Okay? So the first thing we want to get, if you want to get the number of years, okay? And then we want to plot. So we have a function called prompt here, and we go n. We have a function. So we do this. So we just write this out without worrying about what these functions are. So we're sort of sketching our program. And then we want to plot it like this. Okay. And then we think, what do we have to implement here? Okay. So then we stub these functions out. We sketch the function. So we create a function called prompt here. Eventually it will prompt the user, but right now we're just going to output 33, always 33. And then there's plots. Initially, it's just going to plot n I times p, where n is the number of years, I is the interest rate, and p is the principal amount. So it might not be the correct thing to do, but it just gives us a general idea of what's going to happen. Okay, and it just ensures that we're passing the correct values and accepting the correct values back. Okay, and then so this would be stubbed. It would run our program. The result wouldn't really make sense, but at least we know that the general structure of our program is good. And then we'd go into these functions and then fill it out. So it's a way to sketch out your program before you actually commit to it. Way to sketch out sort of the general idea of your program, and then after you know the general picture is going to sort of work, then you can go back in and fill in the spaces. Okay, so so this is coming in from week 6. Okay, so I have a mat file, a .mat file called monthly.milk.mat. So I'm just going to clear my workspace. I've got no variables, so it's all clean. I'm going to go CLC, which clears this command window. So this monthly_milk.mat file is available via Moodle, so you can download it yourself and have a play around. But I'm going to load it here. Okay, and I see that I have these, I have 3 row vectors, all row 1 and 156 columns, so it's 156 data points. I have month, I have year, and I have milk production. So for each corresponding value, this is the month of the year, this is the actual year, and this is how much milk was produced in that month. Okay. So the data is available from here. So this is, the milk production is the number of pounds per cow, okay? So it's not the total milk production, but it's the amount of milk per cow. Okay, so we sort of know what sort of data is inside here. So we want to convert the separate year and month arrays into a combined value. That could be good. Then we want to convert the production. So okay, let's just start a script. Monthly. So let's create a new script. Let's save it as monthly milk analysis. Okay, so I got the script monthly milk analysis.m. And then what I want to do is, the first thing I want to do is load the data. So I want to make sure the data is loaded. So I'm just going to start, so I'm going to do the sketching process. So I want to convert separate year and month arrays into combined value. Okay, so I'm going to, let's go dates, combine month, year, month. So what are the values? The value is milk month and milk year. Milk month and milk year. Okay, so I haven't created the function yet. I'm just stubbing out my program, sketching it out to make just to see the general structure, what that's going to be. Okay, then I want to convert the production values from pounds to liters. Okay, milk pounds. Maybe I just tried pounds to liters. Okay, I'm going to pass in milk, and let's see, it's milk production. Okay, and then I'm just going to call it milk liters. Okay. And so by doing this, we sort of get the idea of what things these functions are going to accept and output as well, right? Okay, converts the production, okay, answers the question, did monthly production increase between 1967 and 1974? Okay, so let's just, for a start, let's just do a plot of the data. I'm going to plot the dates against the milk liters. Okay. So that's my program. Okay, so now I know what functions I want to implement, right? So I want to create a thing called combine month year. So I'm going to go new function. I'm going to call it, I'm going to accept 2 input arguments, months, years, and output dates. Okay. Right now, okay, what I'm going to do is I'm going to combine month, year, combines months and year, month and year values into a single date value. Okay, I won't bother about the detailed explanation, that sort of explains it. I'm going to say combined month here. Okay, so I'm just going to go to the documentation in MATLAB. So MATLAB's got this, so remember when we were talking about different data type before, we have integers, we have strings, etc. MATLAB's got this other data type called a date time, okay? So it's a way to sort of keep track of dates and times. Now it also requires a date, just not a year and a month, but also a day. So what I'm going to do here is I'm going to assume that I'm just going to put the first day of the month, okay? So let's just make sure this is going to create an array of date time values for corresponding elements. Okay, the arrays must be the same size. Okay. So I'm just going to go down here and go, note that it puts the day value as the first of the month. Okay, just so that it's clear what it's going to do. Note that the day value is the first of the month. Okay, I have my dates. My years are years and months. Okay, and then the days, I just want a row vector of just ones, right? First day of the month, of the same size as these guys. So I want ones. Okay, I want one row, and the length, the number of columns is just, say, I'm just going to use months. Okay, so this is going to be the years, the months. This is going to create a row vector of ones of the same length of these guys. Okay, so that's going to be my days, and this is going to give me my dates. Okay, so that's that function done. So let's close that down. The next thing I want to worry about is this function here. I'm going to go new function. I'm going to go here. I'm going to go liters. And I'm going to go LBS for pounds. Okay. Milk LBS to liters does unit conversion of pounds to liters for milk. And then here I'm going to output some liters. Right now I'm just going to put 0 here, just stub it out, right? Doesn't have to be exact. I'm just going to put 0. It's always going to return 0, okay? So we don't have to go back and fix it, but let's just see if this runs. Okay, remember that we probably don't want to connect the data values. We probably don't want to connect the data values like they've done here. That's sort of, remember, that's not such a great thing to do because we actually don't have measurements. It's just implying that we have measurements here. So what I'm going to do is I'm going to just go blue circles. Okay, so I'm going to run this and see what happens. Okay. So again, it's just going to give us all zeros, right? Because that's what I'm outputting from the list, so I have to fix that. But my program doesn't crash, right? It works. Everything gets passed around all right. So I'm confident in the general structure of my program. Now I have to go in and just sort of fix a few things up. So what I want to do first is also put labels on my graph. Okay, so this is let's call it time. Okay, and my Y label will be milk production per cow. It's in liters. Okay, and now I want to fix this up, right? I want to actually fix this up. So I want to come back in here and fix up this function. Okay, so So I'm going to come back here. I don't know the conversion factor, so I'm just going to Google it. So I'm going to go 1 pound of milk in liters. Of course, this is going to depend on various assumptions because, of course, pound is a weight measurement and liters is a volume measurement, so it's going to depend on the density, which is going to change depending on the temperature and the pressure, etc. But I guess he just assumed standard temperature pressure. Okay, so the density of milk is approximately 1.3 kilograms per liter, so a liter of milk weighs very close to 1 gram. Okay, so maybe we convert to kilograms first, so then we convert to, so again, I don't remember conversions between kilograms and pounds, so 1 pound to kg. Okay, so a pound is approximately this many kilograms. Okay, so I'm just going to copy this value and come back into here. Okay, so I'm just going to go kgs is equal to this times the pounds, okay? So that number of pounds gets converted to kilograms. And then using this, I'm going to convert to liters. Okay, so it says there's 1.3 kilograms of milk in each liter, okay? What do I want to do is I want to come back here. So 1.03 kilograms of milk each liter, so I divide by 1.03, right? I get the number of liters. Okay. So I've sort of filled out everything that I need. Let's plot it. There's a lot of data points, so I don't like using the circles. Let's use sort of a small, let's just use dots. Okay. Okay, so this sort of demonstrated the process of just sort of sketching out your program first. Now, you don't have to follow this, right? But you might find that it helps to sketch your program out first before you start filling in the gaps. Okay, answer the question, did monthly milk production increase between 1967 and 1974? So it's 1967 is about here, right? That's 1966, 1968. It might be a little bit small on the screen, but 1967 is here to 1974, which is out here. Okay, and we see that there's a general increase in this, right? So we would say yes. Okay. Okay, so this is just reminders of some of the stuff we did last week. Remember when we were talking about functions that return more than one output? When you call that function, you want more than one output on the left of the assignment operator. And also, if your function returns no output, you don't want to put it in an assignment operator because there's nothing coming out of it to assign. So this is just saying what I said. Remember, we looked at persistent variables. So persistent variables are variables that exist inside a function between function calls. So I would strongly encourage you not to use persistent variables. They're not considered good programming style. They can lead to hard to understand code. But the reason why I included it in the lecture was because you may come across somebody else's code that uses it, and it's good to know what it does. But I would strongly encourage you, if you're thinking that you need a persistent variable, you probably don't. You should probably think of a different way of doing it. Okay. But I wouldn't go as far to say that there's never any situation where a persistent variable is helpful. But those situations are very, 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 very rare. So you have to have a very, very good reason to use a persistent variable. Okay. So just some programming style guidelines. So if you have functions that return values, you generally won't print them out inside the function, right? Because that's usually done outside that function in some other function or script. Functions should not normally be longer than sort of 1 page in length. So this is sort of coming back to the idea that Functions should do one thing and do them well. If you're trying to do many things, you split that up into separate functions, keep your program modular and easier to understand. So pass all values to be used in functions to input arguments in the functions. So if you have a function that accepts many inputs, the number of variables you pass to it has to match the number of inputs. Sort of try to keep things in scripts and command windows separately. So if you want to use a variable, so it should be defined in a script, not in the command window, because the next time you go to run the script, you have to remember to define the variable in the command window, etc. So don't depend on the base workspace being in a certain state before you run your script. Okay, so that was the end of the slides from last week. Now I'm going to start on the slides for this week. So this lecture is sort of fairly short. These slides are fairly short. So we want to talk more about strings, okay? And sort of the assessment that's due in week 10, which is the first week after the break, is all about manipulating strings, okay? So that assignment is about applying the genetic code, sort of to simulate what a ribosome does in a cell to convert from the nucleotides in a messenger RNA molecule into a peptide or a chain of amino acids. So it's all about string manipulation, that assignment. So I want to sort of go over more about string variables here. We've seen them before, but I want to go into more detail. And then at the end, I want to talk a little bit more about program planning. So we mentioned program planning in the last bit, to talking about stopping out your program, sketching it, and I want to sort of talk a little bit more about this at the end. Note that this last part isn't actually in the textbook prescribed for this unit, but you can find a lot of information online about the stuff I'll talk about as well. Okay, so in MATLAB, strings really are just any number of characters which are contained in single quotes. Okay, so you have single quotes, hello, how are you? In single quotes, that's a string. Okay, so as far as MATLAB is concerned, a string is considered as a row vector in which every element is a single character. Okay? A substring is a subset or part of a string. Okay, so you could have a string hello world, and the first part of it, hello, is a substring of that string hello world. Okay, characters include letters of the alphabet, digits, punctuation marks, white space like spaces or tabs, and control characters. Okay, so we've seen a control character, right? So control characters are typically start with a backslash and a letter. So we've seen \n. Okay, that's the control character for a carriage return to go down to a new line. You have \t. That's a control character for a tab. So you have these control characters. There's also a control character for backspace. So it simulates pressing a backspace on the keyboard. Okay, so you have white space characters. This contains space, tab, new line, carriage return. So some of the control characters are also considered white space characters. I'm going to use these terms leading blanks, which are blank spaces at the beginning of a string, or just spaces at the beginning of a string. So you might have 5 spaces, then hello world, and those 5 spaces at the beginning would be called leading blanks. Or trailing blanks are blank spaces at the end of a string. Okay? The empty string is just a string with length 0, e.g. just 2 single quotes without anything inside, just a string of nothing, right? String of length 0. Sometimes when I say empty string, people may think it's just a string with a single character, but a string with a single character is not empty. It has a single character. So by empty string, I'm always talking about this, about the unique string of length 0. Okay. So MATLAB strings, again, any number of characters that contain a single quote. A string consists of any number of characters, including possibly no characters, so that would be the empty string. So the following are examples of strings, okay? So I have empty string, I got a string with just X, string with cat, I got hello there, and then if I could just think about this by itself, that would be a substring of this string, okay? String variables can be created using assignment statements. We've seen this before, right? This just set it so, and then we see in our workspace, we have these values. Okay, the class of the individual elements are characters. Remember that MATLAB just thinks about these as row vectors, where each element is just a character. Okay. Or we could get these if we put the input with an S, right? That's accepting a string input. And then when the user inputs that, this value stored in Unicode will be a string. Okay. So manipulating string variables. So since strings are just vectors of characters, many of the built-in functions and operators we've already seen for operating on vectors will also work on strings. So for example, the length operator will also just work. We'll tell you the length of the string. The transpose operator, okay? So let's just say Unicode from last time, SCI210, right? I've entered that. So that's length is 6. If I want to go from the fourth, so if I want to go from the 4th character through to the 6th character, that'll give me the substring, right? I can transpose it, so instead of being a row vector, now it's a column vector, which, like with each element being a character. Okay. So a lot of the things that we've done with numbers can be also done, so a lot of things we've done with vectors of numbers can be done with vectors can be done with strings, because strings are just vectors of characters. Okay, so remember last week we were looking at this Roman grave data, and we had a look at skeleton ID. Skeleton ID was what's known as a cell array. Okay, so I didn't mention much about this last time, except just a few little things you have to keep in mind when accessing elements from it. But the values are like this. Okay. So cell arrays can be used to store data of different types. So in MATLAB, if you're using vectors or matrices, the type of each element must be exactly the same. Okay, so you can't mix characters and numbers inside a row vector or matrix. They must all be numbers or all be characters. Not so with cell arrays. A cell array can have some things as numbers and some things as characters. Okay, so it has that flexibility there. But another thing to note is that, let's just say we want to keep track of a list of strings, right? So one way you might think about doing this is as a matrix of characters, where each row is a string that you want to, and so each row represents a string, and so you have a matrix, and so you have this list of characters. But one thing about matrices in MATLAB is that each row has to have exactly the same length, okay? Has to be a square table, so to speak. And so if you have strings of different lengths, your rows are going to have different widths, and MATLAB isn't going to let you do that. So one way around that is just by putting extra spaces on the end of the shorter strings to pad them out, so that everything, or you can use cell arrays. Cell arrays will allow you to have the different strings of different lengths. Okay, so that's why skeleton ID is a cell array. It's because these different IDs for the skeletons have different lengths. Okay, so that's one of the most common uses of cell arrays in MATLAB, is to store strings of different lengths. And sort of just to let's just clear everything. Okay, so to enter a cell array, let's go cell array just as an example. Instead of using square brackets, I use curly brackets, and I can just enter my elements like hello and X. Okay, so these strings, two different lengths, it's okay because it's a cell array. Okay, so if I have a look down my workspace, I'm telling you it's a cell array. Okay, and to access the values, I don't use the square brackets, I use curly brackets. So I want to get the first string out, okay, it's going to be hello. I want to get the second string out, it's going to be X, okay? If I try to put this into a matrix where the different strings are on different different rows like that, right? Can give me an error because the strings for a matrix, the row lengths have to be the same. Okay, so I could fix this up by putting extra spaces on the end here. Okay, that would work. But that also has its downsides, right? So there's different trade-offs between these different things. Okay, so this is just how you could do it. Cell arrays, and this is how you access stuff from cell arrays. Also, for example, if I wanted to have a vector with character x as the first and the number pi as the second, it sort of doesn't like it, right? It's not giving me what I expect because it wants everything to be either a character or a number. But if I were to look at a cell array instead, x, pi, it would store this exactly. X, the string x, the character x, and the next thing is the number pi. Okay? So cell arrays, so a lot of the cool things you can do with matrices in MATLAB, like multiply them together and do all these element operations that make like vectorization, that makes things very quick, you can't do with cell arrays. Okay, so there's this trade-off. If you want to do those sort of things, you have to be using matrices, but matrices lack the flexibility of what sort of data they can hold, and cell arrays can overcome that. So there's this trade-off between using either matrices or cell arrays. Okay, so what I'm going to do is I'm just going to go back to the data from last week. So I remember I have this file rome.math, so I'm going to load it. Okay, so remember I have this cell array of all these IDs for the skeletons. Okay, so I can turn it into a matrix using character skeleton ID. Okay, and then what that's going to do is it's going to take a cell array and turn it into a matrix of characters, and it's going to add spaces to the end of the shorter string so that all the strings have the same length. Okay, so you have this character thing that's good for sort of converting between these things. Okay, so skeleton ID. Actually, what did I do up here? What was my last command? So I'm going to call this character skeleton ID just to differentiate them. Okay, so skeleton ID is a cell array. Okay, so I access the individual strings like so. Okay. But remember, character skeleton ID is a matrix of characters now. So if I just give it, typically with a matrix you want to give it two indices, right? A row and a column. But if I just give it one number, what it does is it sort of just, it's just going to give me the first character in the whole matrix. So if I wanted to get the first string, the first row, I would have to do, I want the first row and all the columns. Okay, and that would give me the first row. If I wanted the third element here, okay, so this is the difference between cell arrays and matrices, and it's a thing to keep in mind. Remember, the colon operator without anything just says I want all of that stuff, right? So I want the third row and every column. Okay. Let's look at some operations on strings. Okay, so sometimes maybe you might want to join strings. Okay. So let's just say I have string 1 is hello. Okay. And I wanted to join these into one string. Okay, so there's the MATLAB function strcat, string cat, or cat stands for concatenation, so joining. So for this, I can just pass it my two strings, okay, and it's going to join them together. And it gets rid of this white space here. But we can also remember that these are just row vectors, right? And remember, we can join row vectors together just like this. Okay, so we did this with numbers, joining row vectors together. Okay, and this doesn't get rid of the white space. So why does string cat get rid of the white space? Let's look at the documentation. So it says, for each character array input, string cat removes trailing ASCII white space. Okay, so this join just joins everything together as it is. Okay, but string cat is going to cut off any white space characters that are trailing on these strings. Okay, so that's why it does that. So it's good to be aware of these differences. Okay, so vertical. Okay, so you have two strings. I got string 1. So let's just rename string 1 to be hello without space, string 2 to be there. Okay, so I want to keep these two strings as separate strings, but I want to put them in as the rows of a matrix. I can go string 1, string 2, like that. Okay, so nothing bad's going to happen because they both have the same length. Okay, I could also put character string 1, string 2. It's going to do the same thing. Okay, this method is not going to work if they have different lengths, right? It's going to say, I don't like it, you have to have the same length. Whereas this method will still work if they have different lengths, and it will add trailing white space, trailing blank, just to pad it out to make sure everything's got the same length. Okay, so this won't always work. This will give you an error if they don't have the same length. This will always work, and it's going to pad the things out by adding trailing white space. Okay, so I mean that's just saying what I just said there. Okay, so we have some functions. We have blanks x, so that just creates a string of 8 spaces. So for example, I could have happy times and just blanks in between, so it's going to create happy, then 8 spaces and times. Okay, and remember this is just joining, concatenation, all of these things together. Then we have the thing called d blank, which just removes all the leading and trailing white space. Actually, no, sorry, d blank removes trailing blanks. So let's just double check that. So just trailing white space. Okay, so you still have this white space at the beginning, but just gets rid of the trailing white space. Okay, so any other space like inside of here is still going to keep everything. It's going to keep the leading white space, but it's just going to get rid of the trailing white space. So all this white space at the end is just going to cut off. Okay, then we have str_trim, which stands for string trim. It removes the leading and trailing white space. It's going to remove this white space here, and this white space here, but any white space within the string between characters, it's going to keep. Okay. And note that there's some other string functions. So for example, we have upper. So this converts all the lowercase characters in a string to uppercase. We have lower, it converts all the uppercase characters to lowercase. Okay, so what I'm going to do is I'm just going to pause here for about 10 minutes and then we'll start back up again. Okay, so before the break we were just discussing these various functions you can use on strings, blanks, the blanks, string trim, str_trim, upper and lower. Okay, there's also a function called sprintf. So we're already familiar with fprintf, right? So fprintf is a way of printing to the command window. You can also use it to write to a file. But there's this alternative, sprintf. So sprintf doesn't print anything. It just returns the string. Okay, so so it's a way of constructing, I guess, more complicated strings. So for example, so this is an example here. Okay, so I want to create a string. Okay, I don't want to print this. Okay, I just want to create a string for now, which is a random integer is with a random integer. Okay, so what I would do if I was doing fprintf, right? I just write a random integer is, then I want to insert this value into here, right? So if this was fprintf without the assignment, this would just print this, right? But I don't want to print it. I just want to store what that would print into a string. So instead of fprintf, I go sprintf phrase. Okay, so phrase now is a string that contains what would have been printed to the screen with fprintf, right? And then what I can do is I could say add. I can then use this later and say add 3 exclamation marks to the end and see what this is. Okay. So that's the difference between sprintf and fprintf. Fprintf will print to the screen. Sprintf will take what fprintf would have printed to the screen and just store it in a string variable. Okay, and you can manipulate that more later if you like. That's this example problem. Write a function name underscore skeleton that will receive the location code ET, which stands for that cemetery outside of Rome, or F stands for this cemetery, or T for this cemetery. So it takes this ETFT and the skeleton number, say 18 or 10D, and recreate the skeleton ID. The function should convert lowercase letters to uppercase. Okay, so for example, I could have something like that. Okay, so it's a fairly straightforward function. New function. So I'm going to call it name skeleton. I'm going to go return the ID. Since this is just a quick example, I won't bother with the comment, but of course, you should always comment your code, but it's just a quick example, just to demonstrate. So I'm going to take the, what do I want to call this? Location code with the skeleton number. Okay, and then really all I want to do is I want to concatenate them together. Okay, and then what else does it say? It says to make sure all lowercase letters are uppercase. Okay, so we're just going to go up or around this. Okay. Let's close that down. So I'm going to have this function named skeleton. Let's say I put F69A like they've done here. If I put a lowercase f, it should convert it to an uppercase. Okay, so I can join them together in uppercases. Okay, great. Okay, comparing strings, okay. So strcmp, so note that if I have two, so let's think about this, okay. So I have a string, str1, which is my string here, str2, which is my string 2. And let's just say I want to see if they're equal. I mean, of course they're not, but let's just say I want to see if they're equal. So you might be tempted to do something like this, right, just to check if they're equal. But that's not going to give you what you think it's going to give you, right? So you just want a single true or false answer. But this is going to be an element-wise operation. It's going to go through each element and compare each element separately, right? So it's just going to give me all zeros because all the elements are 0. And if I have string 2 is equal to there instead, so now string 1 and string 2 have got different lengths, if I go string 1, string 2, I'm going to get an error because they want the same length, okay? So this is not what you want to do if you want to compare strings, okay? MATLAB provides this function strcmp, which will compare the strings. So if I go str1, str2, okay, they're not the same. If they are the same, then it will return 1, okay? So don't use the equality operator, okay? And there are different variations. So strncmp compares only the first n characters. So if I go help strncmp, so you give it an n value and it will only compare the first n characters. So for example, it could be strcmp, and I could have ABC and then AAA. Of course, these aren't equal, but if I just look at the first character, they are equal, right? The first characters are equal. Or I could have, say, AB, and then if I look at the first 2 characters, that would be equal, right? But if I, say, look at the first 3 characters, they're not equal anymore, okay? So, of course, string comparison is case sensitive. So, strcmp between hello and hello, the different strings is going to give you false. But MATLAB provides strcmpi, which ignores cases. Okay, so I can go strcmpi, and for this should be the same because it should ignore the case. Okay, and then you can have this with ignoring cases, strncmpi. So ignores the case and only compares the first n characters. Okay, so just a combination of these two functions. Okay, so you have strFind, which finds all occurrences of a substring within the string. This function returns a vector of the indices of the beginnings of the string, or an empty vector if the substring is not found. So let's have a look at what this will do. So let's say strFind. Okay, so let's say hello. Let's say hello Alex. Hello Sarah. Okay, so that's my string. Then I want to find the substring hello. Okay, so it says that it found one hello beginning with the first index, and it found another one beginning with the 13th index. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so it found 2 hellos, one beginning at index 1, one beginning at index 13. If I were to go an W on the end, it won't be able to find the substring because that whole substring does not appear. So just give me an empty vector as the output. Okay. Then we have strrep, which stands for string replace. It finds all the occurrences of this string and replaces it with this string. They don't have to be the same length. Old substring and new substring don't have to be the same length. Okay? So for example, let's go back to this. So we're going to go strrep, and instead of saying hello, I'm going to replace every hello I find with hi. Okay? Not the same length. So every hello gets replaced by hi. Okay? Okay. So if I had a string, and remember I can go d blank, which removes all the trailing white space, and strtrim removes all the leading and trailing white space. Let's say I just want to remove every space, whether it's leading or trailing, whether it occurs in the string. Okay, so I could just go strrep, any space, replace with the empty string. Okay, and that gets rid of all the spaces. Okay, of course that's not all the white space. You still could have tabs and new lines, but you could do this multiple times. You could take the result of this, and then you could take the result of that, then replace any tab. Remember, tab is this control character, \T. Replace that with empty, with the blank string as well. And of course, it doesn't change anything because this contains no tabs, but you could repeat that for all your white space characters and remove all the white space if you wanted to. Okay. Then we have these is functions. Okay, so we have is character tells me whether the elements of the vector are characters. Yes, they're true. But if I'm just got vector 3, 4, 5, it's not characters, right? Tells me if they're letters, right? So this goes through each character and tells me if it's a letter. So of course the first two are letters, but the last three are digits, so they're not. Then you've got is space. So the first one isn't a space, of course, but the next one is. The last one isn't. So MATLAB has lots of these is functions. Okay, converting between strings and numbers. Okay, so in MATLAB, the number 38 and the string with 38 in it are two different things. Okay, they're not the same thing. This is a scalar value of single number 38. This is a row vector of two characters, the character 3 and the character 8. They're not the same thing. But maybe you want to convert between them. So you have this, but you want that. Okay, so you can go what's it? Int to string 38 will give you the string with the characters. Okay, and so you see that after you do this, if I get the length of the number, it should be 1, right? Because it's a single scalar value. But if I get the length of the string, it's going to be 2, so 2 characters. Okay. Of course, you can go the other way. You can go num to string, which will take, sorry, this is int to string, so just a plain integer. If you want to have a number with decimal points after it, so it's not an integer, but a general number, you go num to string. Okay, and I convert, so this is the character, so this is the row vector with the character 3, the character full stop, the character 4, the character 5, the character 6, the character 8. So it's got length 1, 2, 6 characters. Okay, so its length is 6. Okay, so some notes. Remember, don't use the equal sign to compare strings for equality. And while I'm saying this, don't use the equal signs, these equal signs to compare vectors for equality. If you've got two vectors and you want to see if they both contain exactly the same values, don't use the equal sign. The only time you're going to be using these equal signs is if you're comparing scalar values, single values. So if you're string, you can use the strcmp function and its variations like strcmpi for ignoring case. There's also this function is equal. So if you want to determine whether two row vectors are the same, you don't use the equal, double equals, you would use something like is equal, okay? Only use the double equal if both of the values are scalars, single values, okay? Although sprintf and fprintf have the same syntax, sprintf creates a string, whereas fprintf simply prints, okay? The easiest way to create a vector of strings with varying lengths is to use CAR, which will give you a matrix of characters, and it will extend the shorter strings with spaces at the end so that you have the same length in each row. Okay. Of course, if you're going to use this, when you start pulling out the strings, you're going to have some strings with extra spaces attached. So when you're using it, maybe when you're pulling out these strings, you might want to apply d blank to it to get rid of those trailing spaces at the end. Okay, make sure you use the correct string comparison function. So if you want to ignore case, use strcmpi. Okay, so I just want to finish off this lecture with a little bit of a discussion around program planning. Okay, so this isn't in your textbook, but it's in another textbook, which is MATLAB for Engineers by Holly Moore. Again, a lot of this information you can find a lot about pseudocode and flowcharting on the internet. So I just want to give you an introduction to these areas. So, so this material isn't assessed in any way in this unit, this program planning material, but you might find it helpful when you do the assessment to plan out your program a little bit first. Okay. As your programs become more complex, it becomes important to plan your program before you just start sitting down and writing code. Two common approaches are pseudocode, which is a verbal description of your planned program. So you just write what your program does in prose, English or whatever your native language is you want to write in that, that's fine. A flowchart is a graphical description of your planned program. Okay. So for the relatively simple programs in this unit, pseudocode is often the easiest or the most appropriate approach. So how do you do this? So just get out a piece of paper, right? And on the paper you write the statements that describe the steps you need to write the program. Okay? You don't worry about writing MATLAB code. You just write in English or whatever language you want, what steps you need to take. These are usually written in everyday English, not commands that will be used by MATLAB. However, we can easily convert these short statements to commands later. Okay, so these statements you write down on a piece of paper, you want them to be fairly simple, right? You don't want them to be complicated, right? You don't want the statement to be launch rocket to Mars. Okay, that's a complicated thing, and that by itself is hard to convert to MATLAB. You want to have each statement to be simple enough that it's relatively easy to convert to MATLAB commands. Okay, so this will help us plan our program before we write it. Okay, so once you have this down on paper, just open up a new MATLAB script and just put comments in, right? And each comment corresponds to a statement you wrote down on a piece of paper. So that's the outline of your program from your pseudocode. Then what you want to do is you want to just go in beneath each of those comments and just fill in the MATLAB commands to do it, right? So it's a way of you thinking about what your program is going to do before you sit down and you start putting stuff into MATLAB. Okay, so let's look at an example. Very, very simple. Converting from degrees Celsius to Kelvin. So let's create a script that converts a user-defined temperature in degrees Celsius to Kelvin. Okay, so let's go new script, and let's just save it as temp convert.m. Okay, and then of course I'd probably do this by hand first, just write down the steps, but I'm just going to do it in the comments. So okay, so we first need to get input degrees Celsius from the user. Okay, that might be my first step. My second step. Okay, so I could make the program more complicated by checking that the values make sense, right? So checking that they enter a number, checking that they don't enter a value below absolute zero, say. But I'm not going to bother, it's just a simple example. Convert from, so I'm just going to go degrees C, convert from degrees C to Kelvin, display result to the user. So of course, if you're creating a more complicated program, you'd have many steps, right? So you plan your program out on a piece of paper, come into MATLAB, create a new script, and just put those steps in as comments. So that's your planning phase. And then you can come back in here and start writing the commands you want. Okay, so let's put, I'm going to go Celsius is equal to M input, enter the temperature in degrees Celsius. Okay, and I'm going to convert to Kelvin. So I should remember this, but it's 248 maybe. So let me just double check that. $273.15. Okay, 273.15. So I wasn't so far off, but okay. So that's the conversion to Kelvin. F_f. Okay, so here it's sort of a fairly simple example. It's sort of a little bit artificial because here we're just one instruction. But of course, your pseudocode statements could be a few instructions in length, right? But not so difficult that you have to sit down and think really hard how to convert that into MATLAB code. The temperature in degrees C is Kelvin. U line, I'm going to put my Celsius and my Kelvin. So although this example is a little bit artificial, it sort of just demonstrates the process, right? Write down the higher level steps on paper, fill it out, so enter that into a script, then you can just fill it out, okay? So I can run this now. So let's say it is, I don't know what the current temperature in Armidale, maybe the current temperature in Armidale is about 16 degrees Celsius. So the temperature 16 in degrees Celsius is 289.15 Kelvin, okay? Then we could fill in the code. Okay. Another example, so remember a few weeks back we're looking at the Reynolds number. And we're looking at in terms of, we introduced in terms of flying insects or the sea butterflies that fly. So we have this length scale. So in terms of a flying insect or something like that, this length scale, you could take the chord width of the wing. So we could have this basic structure. We're going to ask you use the input of the velocity, the input the chord length. Then let's just say we're wondering whether they're in air or water. So this, remember, this is the velocity, the length scale of the chord width. This is the dynamic viscosity of the fluid. So we ask what the fluid is, air or water, and that's going to give us a different dynamic viscosity. Then we're going to use an if statement to calculate the kinematic viscosity based on the fluid. So this is going to depending on whether they say air or water. Calculate the Reynolds number and display the result. So I've sort of had pseudocode to map out what my program's going to do. Okay, and then I could go in and just fill this out, right? I'm not going to do it here, but you sort of get this picture from the last time. Okay. Of course, you can have a very complicated program. You could have programs with many sub-functions doing things all over the place. And when you start having more and more functions, sort of more and more separate modules working together, flowcharts can be are sort of the more appropriate thing for sort of thinking about the flow of your program, so to speak. So you can create a big picture of your program graphically. This is your flowchart. Then you can convert this flowchart to pseudocode, which you can enter into MATLAB as comments. So it's sort of, you can sort of combine flowchart and pseudocode together. So we'll see this in a second. Okay, so these are just, of course, you're not assessed on this, so you don't have, you can use whatever symbols you want, right? But these are sort of there's like a standard flowcharting symbol, so to speak. So an over represents the start or end of a program. Arrows represent, so now I'm going to this. So an arrow represents sort of the execution flow of your program. This parallelogram shape represents getting input from the user or output to the screen. A square is just some process, so calculating, say, the BMI from the height and weight of an individual. And this square, this diamond represents a decision, so it's sort of like an if statement. So if something is true, then yes, we do this, no, we do that. Okay. So for example, a flowchart for our Celsius to Kelvin conversion could look like something like this. We have a start, we have an end, and then the first thing we do is input temp in degrees Celsius. Then we calculate the Kelvin temperature from the Celsius, then we print temp in Kelvin, okay? Okay, so we could create something a little bit more complicated, right? So it says, now adjust the program so that if the temperature is above 300 degrees Kelvin, a hot warning is given. And if the temperature is below 273 degrees Kelvin, a cold warning is given. Okay, so we have the same thing, input temp C, then we calculate the Kelvin, and then we have this decision process. Is the Kelvin temperature larger than 300? True. Okay, then I go hot, and then I follow these arrows down to this point here. Okay, but if this is false, then I go to this decision. Is K less than 273? If it is, warning cold, then I follow these arrows down here. But if both of these false, I just end up here. So after this, I will end up here in either case. Then I print the temperature in Kelvin, then I end. Okay. Okay, so of course, Google MATLAB flowchart, you'll get a lot of results. So the thing that I would suggest is combining flowcharts and pseudocode is a good thing. So I would flowchart the general structure of your program. So instead of putting individual instructions in here, I would put high-level commands that will be turned into functions. Okay, so your flowchart is going to be a very, very high-level look at the flow through your entire program. And you're going to be just thinking at the level of in functions, not MATLAB commands. Okay, just think at the level of functions and not MATLAB commands. Okay, so very high level overview. And then for each of those functions now, which is represented by a box in your flowchart, do pseudocode for that function. Okay, so that's one approach that could help you sort of plan out a more complicated program. And particularly if you're doing SCI210, not 210, if you're doing SCI210 and you're doing that final project, that planning phase could really, really make your life a lot easier once you start writing the MATLAB code. Okay, so just a summary to finish up. Typically, the more time you spend on planning, the less time you will need to spend changing your program later, because if you start programming, you'll think, well, I didn't think about that before because I didn't plan that properly. You have to go back and change things. The more bugs you're going to get in your program because you didn't think about the whole thing together. Pseudocode is often the most appropriate for simple programs. Flowcharts can help you plan more complicated programs. I would suggest you to use both of them together. So flowchart, the very high level view of your program, is thinking in terms of functions. Then for each of those functions, do pseudocode and convert them into MATLAB commands. Okay, so I want to finish up here. Thanks for listening, and I hope you guys enjoyed the 2-week teaching break, and I'll see you guys after that.